I'm guessing you're already seeing me. So let's start another problem that I haven't solved before. This, based on the rating, looks like an easy one, but I hate parsing expressions. Let's see. Okay, let's set up a timer and go. So signature. Boolean expression is an expression that evaluates to either true or false. Okay, it could be in one of the following shapes. T evaluates to true, F evaluates to false, evaluates to the logical not, okay, and evaluates to logical and, evaluates to the logical or. Okay, so we are given a string. Expression, I'm guessing, which is string, and we need to return a Boolean value. Tests. So can there be an empty string first of all, in each case? Let's assume impossible. Let's now do something like T. So I'm assuming this is something that can happen. So we are evaluating from the left to the right, and when we encounter some symbol like this, we evaluate expression on the right. So essentially that is the same is true and not false. So it evaluates to true. Then also, like, let's say not false, and it can be something like and not or. And let's say here we also can have like and true, true, and or false, true. And I think this should relate to true if I'm not missing anything. So not false and not, okay. Actually, let's say this. And not or. So this is false. This is also false. Okay, question, can we actually have something like TF? So TF is false because it's like T and F. Or we can only have like secret. So what's allowed? Oh, we are not allowed to use something like that, so it's a little bit simpler. We cannot have strings like these. We can only have strings like these, where all expressions are separated with some symbols. Okay, here we also can do something like this, right? So it can be not, and then, oh, and after not, we also need to have brackets. So fine. So this will be false, and this will be false, and both of these will be false, and not will be true. Okay. So So that's the only thing that we can have. Now this will be a string that doesn't have any spaces in it, I'm assuming. So let's now figure out the solution. I see a clear recursive relation. So once we encounter any of those symbols, we are expecting to see a sub-expression that we need to run our function on. So I'm thinking about how to parse this properly. So we want to process the string from left to right, and when we encounter any of those symbols of like this or and, we will be running a new function starting there, and like we will be recursively reusing the same function. So we will create a function called process expression, and it will take several arguments, like operation and expression and I. So we'll be processing starting at I, and then we will be iterating over all the symbols. So when we encounter this, we ignore it. If we encounter the new symbol, we call the recursive function. If we encounter T or F, we read them as true or false. And then once we collect all the elements, we just apply the operation that we plan to apply. Okay, so how will this be in terms of the running complexity? We're only moving from left to right with our pointer, and we will be doing, let's say that length of the string is n, length of expression equals n. So it will be of on runtime and of number of nested expressions space because of recursive stack that we need to store. Yeah, and otherwise this will be it. Okay, so let's do the implementation. So define process with operation and so does it always start with some expression? No, it can evaluate to just true or false, right? But that would be the only scenario where we start with not one of those three symbols. So here we will just return if expression equal t return true, if expression expression equal f, return false. So now we assuming expression starts with one of it can start with and, not, and this. And then we will always have this recursive process where we are just continuing, like we start, then we know the operation that we need to pass to this process function. And I will be an index. So then while elements will be this. Do I want to process it differently for not? No, I don't. Okay, so elements and while expression of I is not equal to closing bracket. I'm also assuming that all of those are valid, so we don't have any crazy expressions. So if expression I, and also we will always have this closing bracket, so we don't need to check if our I is at the end of the string. It would mean that we haven't closed one of the brackets, and that would make it an invalid instance. So I will not be checking for this. If expression at ith place is equal to f elements and false, elif equal to true, elements append true, and I plus or equals 1. And then once we have finished, we do I plus equals 1. Oh, we need to, we haven't discussed, so operation will be string and I will be integer, and we will be returning a tuple of Boolean and integer. So we will also be returning the current I after we process this expression under the hood, like one level deeper. So now what do? We check the elements. So if operation equals not, return not elements pop. And another thing that we are returning, yeah, obviously I haven't processed yet what happens. Elif expression, let me first process that. Expression I in this or this or this. I will just make it a set so that it's a little bit cleaner. Checking this should be checking a set. Then what do? So we do element I equals, okay, here we would be I plus or equal 1, here will be I plus or equal 1, but here we will not be doing I plus or equal to 1. We will know where we need to put the I, because we are now calling this process of operation that will be expression I, and I plus or equals 1. So, sorry, I plus 1. We need to start with the next element, which will be the opening bracket, and that's fine. So then we can now do elements append element. Okay. So now if operation is this, we return not elements pop. And we return elements pop, and which I do we need to return? The new I. Yeah, we have corrected this. Actually here, else I plus or equals 1, because to make everything consistent here, I need to do like this. Elif operation is equal to end. We return all elements, else we just have 3 possible operations, so it's one of those. Any I. And now finally okay, so now we have process of operation, which is the expression at 0 place. We start at 1, and this will be result, and I will be this. Return the result. Okay, so I think this should be a workable solution. Let's now check that it works on something relatively sophisticated like this. So nice, we have the string and we have our pointer, which is at 0. We start processing as expression at 0, and the pointer goes to 1. So pointer goes here, the expression becomes this. Okay, so we are calling this. Now we control for this. Okay, so elements, we are starting to populate the elements. On the first iteration it will be, we just cannot do anything, so we move the pointer here, so it's not F, not T, and not one of those symbols, so we are just moving it to the right. And here we encounter another operation. So what we do, we call another operation, which is this, and where do we call it, right? The index was at this point, so now we are calling it at this point. So we are calling it at 0, 1, 2, 3, index 3. So now at index 3, for this iteration, we start iterating, and again, we ignore this, and here we will call it another time, so we will call it as AND operation, and at index 5. So, okay, now we are calling this the third loop. We call it at index 5, so we start here. We ignore this. This we don't ignore. We finally start adding the elements here, so we add true. And we continue. Okay, we have spent 20 minutes. Let's spend 20 more. And here we have added our T, and then we have added our F to the elements. And in both cases, we are moving I plus 1, okay, and the comma we ignore. So then we finally encounter this symbol, and that would require us moving I one more step. So it will be moved here. And then we will be returning. So we will be returning from here. We'll be returning AND. And this AND 5 symbol will be returning AND, which is false. So now it means that here, the first element, we will be ending as false. Yeah, we are appending this element, and we will be continuing from this in this second call. So we continue and we encounter another operation. So we now call it as this at index whatever it is, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. At index 11. So let's now start collecting things. We will call it, oh, I think it's in index 12, right? Because we are calling it at I plus 1. So we are ignoring the opening bracket, and then it's false. We populated it with false, and then it's ignoring comma, and then it's another false. We populate it with false, and then it encounters a closing bracket. So once it encountered the closing bracket, yeah, we need to do one last plus or equal to 1 here, right? So we need to encounter the closing bracket, and now we are done. So we need to move it a little bit further. So that's what we do, and we also return to the previous function. And what we return, so we were calling it as OR, and it will be returning F. So that means that here we will be adding another element that is F, and now here we will be encountering another bracket, and this would mean that we will be encountering brackets. So we are moving this again, and here we were also doing OR between these two, so now it's F, and we will be returning to the top level. So at the top level we will be also encountering the bracket, so we finish, and the operation was not. So at this case we will be returning true because it's not false, and we will be moving our pointer out. Oh yeah, we will just be returning this operation, so we will finally return it to the top level, and we return the result. Okay, it does look like this is the right solution, given that we actually processed everything correctly. Wow, nice. Well, I think that was one of the fastest hards that I have ever solved, and one of the nicest solutions, one of the cleanest ones. Happy to be here at this point, because those are hard problems. not to miss any corner case. But out of all such problems, I think it wasn't especially hard. And the recursion here was relatively simple. Okay, thanks everyone. See you next time.